Earth produces a certain amount of ecological goods and services, lumber, and trees, and oxygen each year. And humanity is now using up that year's supply of production sooner than a year. So they call it the overshoot. Once you've used up the year's ecological goods and services, you're now borrowing from the next generation. You're going into debt, ecological debt. So we're in massive ecological debt. Deep ecologists like myself, we think about this stuff, and it informs our work.
In a world increasingly facing the challenges of climate change, with the Building Green podcast, we will dive deep into the intersection of architecture, design, urbanism, and environmental responsibility. I'm Ladina Schipp, your host. I've been an architect and building site manager for the past 10 years. During my studies at ETH in Switzerland, as well as in my working environment, I've had many touchpoints with sustainability, like many of you, I guess. I've also learned to question what I've been told, which is why I decided to go deeper into the topic and uncover what sustainability actually means. My mission is to highlight the transformative power of sustainable architecture, not just as a practice, but as a catalyst for broader societal change. Subscribe for more of our content and enjoy the show. So with over 30 years of experience in sustainable architecture, can you recount the early days and what initially drew you to focus on designing with earth care in mind?
I'm Todd Jersey. I'm architect. I have a firm, Todd Jersey Architecture, and I'm also the head of architecture for Shibusa Systems. So I was a builder. I was a trained builder before I went to architecture school. And then, so I've always loved construction. I'm sort of construction and making things first, and then an architect, sort of as a part of that. So I went to architecture school and got out, and one of the first projects I did, which was where I was out looking at the construction site. It was kind of a fragile site. It had a lot of, it was in California in the Oakland Hills, and it had a lot of existing wonderful old trees. And in order to get the foundation in, the bulldozers came in and drilled and sort of ran over the trees. It was just a lot. It was kind of shocking, the environmental impact on this site that was actually lovely. It just sort of denuded the site, and it was heavy-handed, and the foundation was massive, and it was discouraging to me to see this kind of impact on just a single-family home site in the Oakland Hills. So I was discouraged, and then I decided to try to find a different path to have construction and architecture have a lighter hand on the site. That was really my first, and at that point, I didn't know anything about green or sustainability. It wasn't even taught as a thing in schools. We didn't have any language back then. So I started searching around and reading magazines. There were some magazines that were so this was the early 90s. Yes, this was early 90s, like 1990, 91. So 30? Yes, 30 something years ago. So, and I happened upon an article by this kind of wild, wonderful architect named Pliny Smith. Pliny Smith? I think it's Pliny. I might be butchering the last name. But Pliny had he's down in Texas, and he had this organization he called Center for Maximum Potential Building Systems. And I was completely intrigued. Whatever that is, I'm interested. So I called Pliny. He said, go read the book Permaculture and call me back. So I bought the book Permaculture, and that changed my life. It's the stuff that I thought, oh my God, all this should be taught in architecture school. It's all about earth ethics and earth care and building and integrating systems and systems approach to everything, and how one thing affects another thing. So that's ever since then I have been extremely motivated and excited to both learn, the sort of unlimited amount of wonderful things, just like I did when I picked up the book Permaculture and changed my life, continuous learning, and then applying what I've learned into the marketplace. And I've been the leader in both of those. I think and Katy knows this, I'm deeply mission driven, only because I have a sort of a deep care and deep earth ethic and deep connection to the earth, which is why when I went out to the site and it was butchered, it really affected me deeply, and why the book Permaculture also was transformative for me. So long-winded answer to sort of the start of a trajectory that's been sort of ever present and not ending for the last 34 years.
Very interesting. I'll ask you after Katy introduces herself about the key principles you learned from the book, because that really intrigues me. So, Katy, you mentioned it before, and you had a transition from corporate finance to green home building. That's quite unique. What inspired you to make this change, and how did your previous experience inform your approach at Shibusa Systems?
Thank you, Ladina. Yes, as you mentioned, I'm Katy Reynolds, and I am founder and chief executive officer of Shibusa Systems, which we founded about 5 years ago to really provide a more purposeful solution to the housing crisis and the labor shortage across the U.S. and actually around the world. And as you said, I'm kind of a reformed investment banker. My career for 35 years was on Wall Street and in finance. But the last part of my career in finance was in private equity, focused on the clean tech space. And so I worked for a private equity firm that was buying up LED lighting companies and other clean tech building materials. And it gave me exposure to the built environment. And I got to see real estate development and construction up close, and realized, 10 years ago that it was the most wasteful, actually 15 years ago now, the most wasteful industry I'd ever seen, and except for maybe mining. But I just realized there was so much waste in real estate development and construction. And I really, when we came out of the Great Recession, and I was just really tired of Wall Street and finance, I left and really wanted to do something to leave a more positive legacy. And so I started my own real estate development company to prove that you could build uber green and sustainable for the same cost as ordinary. And when I was working in private equity, even though I was in New York, I was spending a lot of time in California, and I was actually going to see large homes in Silicon Valley, and projects that were green and sustainable. But all of those projects were asking investors to forego financial returns for environmental returns. And I thought, coming from Wall Street, I know that we'll never make it in sustainability and resiliency until we have a solution that gives financial returns too, because people are not going to change if it's not green on the bottom line. So I set out to prove back in 2011 that you could build uber green and sustainably for the same cost as ordinary. And so I started a project in Sacramento, 80,000 square feet, mixed use residential development, 6 stories. And we completed the building in 2015. And it was the very first LEED Platinum net zero energy building in the US to be done at market cost and to give my investors greater than market rate returns. And so it was really a grand slam for us. We had a self-generating elevator. We had 12,000 square feet of solar on the building. We had stackable parking. We had vertical farms and urban farms in on the second floor of the building. So we really incorporated gray water recycling, a lot of really innovative features that had not been all combined and done before. And so with that project, I started doing consulting work around the United States, and I ended up in New Orleans, where I'd never been before, and got to see Brad Pitt's Make It Right neighborhood in Global Green out of Santa Monica, California. Global Green was founded by Leonardo DiCaprio and Gorbachev back in the 1990s. And they had built these just really funky, supposedly sustainable green homes, but they were all falling apart and falling down. And people in the lower Ninth Ward of New Orleans, who are some of the most income challenged people in the United States, couldn't maintain these homes. So that is when I began really thinking about developing a company to build really green, sustainable housing that was affordable and easy to maintain long term, and would really provide a much healthier, better environment for the residents living in these homes, and really help them save a lot of money long term to create more generational wealth. And so that was kind of the genesis for Shibusa Systems and how we launched in 2019. And, I really needed to find an architect that really understood not only architecture, but building science, and really had spent a lot of time understanding building science, building materials, and, but keeping it simple. Because I think a lot of times, especially in California, there's so much money, people just overcomplicate things. And we just really need simple, resilient, high quality homes. And so that's how Todd and I met in my quest for a leading design professional that really had a building science background. And so Todd came on board Shibusa Systems as our head of architecture and building science. And my background obviously is in finance, and my co-founder, Mike Wynn, came actually from Silicon Valley. So he has a technology background, but the three of us really make a great triumvirate or whatever to really help tackle this problem from different perspectives.
Wow, what a strong team. So Todd, could you, from the architectonical aspect, elaborate on what makes Shibusa Systems or projects done with your system more efficient and less expensive than what Katy mentioned was like the traditional way of doing sustainable architecture, which was much more expensive and inefficient than what you do?
Well, Katy could also explain this because it's really her vision of combining systems, building systems in a way that are easily assembled on site. And so what Shibusa Systems does is this sort of this wonderful three parts to it. It uses building systems that are already available and that could be cut and pre-cut by existing factories and manufacturing facilities and brought to the site. And then these can be assembled precisely. They're precision cut, and they can be assembled easily on the site by not unskilled labor, but there's sort of the laborers and then the skilled laborers, and by trained assemblers that Shibusa Systems trains. So what that allows us is a couple of really important things. One, the buildings can be pre-manufactured, which is really a source of savings, right? So a lot of labor savings. It's also savings of time, and they can be brought to the site. So these systems are really pre-cut without Shibusa having to create a factory. So Katy can speak more to that. And then the systems are brought and assembled by people who do not have to have the skills of a regular home builder. So you're opening up this you're opening up home building to a wide variety of people who have like no skills. They can actually become home builders, which is like totally game changing, and not just in terms of sustainability, but social equity, social justice, community building. And then the environmental piece is one of the main environmental pieces is there's like 5% waste, whereas a standard conventional construction site is the waste is in the low 30s to mid 30%. So we're, that has major impacts. We're much more resource efficient, of course. The building systems we're using, the exterior envelope of the building is what's called structurally insulated panels, which is way more, way higher performance in terms of insulating than a standard conventionally constructed building. So the buildings have a level of, and I should say this too, because Katy and Mike have been working on this a long time before they brought me in. There's an extremely high level of care and environmental and social ethic that Katy and Mike both bring to this company that really attracted me, because I'm an advanced, I'm in my, later part of my career. I've established myself as one of the top sustainable architects. I don't need to work with anybody. But I was really compelled by the community vision, not just the environmental vision, but the community vision of Shibusa.
You mentioned you have much less waste than other traditional building sites. Is that due to perfected construction processes, or because you recycle, or do you mean in the building process because there is not each person or contractor that comes with like his material that's packed in package? On which point do you focus?
Yes, when you go to most residential construction sites, you see huge dumpsters, a ton of waste. Most homes are built with lumber. Here in America, we say 2x4s, and a lot of sheetrock and panels and stuff. And most of that, people run to Home Depot or Lowe's or their local hardware store and just, they overestimate how much materials they need. And a lot of times, because they make a lot of mistakes and have to throw stuff out, people steal stuff off the site. So they also don't measure accurately. So what we did, for instance, with say lap siding on the side of a house, we know that the panels come in 12-foot lengths and are 7 inches in width. And so we developed an algorithm to say, okay, if we have, our sides are 20 feet long and 26 feet deep and 20 feet high, how many, let's develop an algorithm to optimize the pattern of the lap siding so that we know how to cut those panels and put them in a pattern to optimize the number of lap siding panels that we need. And we did the same thing with the panels that we use in flooring and interior walls. And also, Todd mentioned that we build our building envelope with structural insulated panels, which are made from OSB with oriented strand board sheets, which is like a rough plywood on either side with the insulation compressed in the middle. And those big plywood sheets come in 8-foot widths and 24-foot lengths, and they get put into a machine. So we have optimized how we cut our panels at the factory so that we really minimize any waste of those products in the facility. And then the same with our heavy timber framing. All of our posts and beams are prefabricated so that the lumber is optimized in the factory that's cutting and fabricating those posts and beams for us. So that when those posts and beams get to site, they're already cut with our proprietary joints on the end, and they're already stained. And so then the guys on site, they don't have to do any cutting and sawing We don't have to worry about them making any errors because they've already been precision cut at a facility and flat packed and shipped to the site. And the guys on site, all they have to do is put the posts and beams together and lag bolt the joints in place. And then they just have to slide our SIP panels tongue and groove into the framing system. And so we've really spent a lot of time optimizing every square millimeter of our housing. And that's how we have less than 5% waste in our homes. And the reason why conventional construction has greater than 30% waste. We do not have dumpsters on site. At the end of the day, whatever waste there is can be put in garbage bags and taken away.
So can you walk us through the process that a homeowner would go through? Does he come to you from any part of the world, buy like a pre-designed house and you produce in the US and ship it? Or is there a way to collaborate with you in the design process already and to produce anywhere else in the world to not ship that far?
So right now we're starting in the US, but our goal is to be global. And obviously, we're in feet and inches in the imperial system here in the US, and we will have to convert to the metric system once we go abroad. But we do not manufacture anything ourselves. And we use what's called distributed manufacturing. So we have suppliers all over the country because we're looking right now at building in Hawaii and on the West Coast. We're very deep in building here in the deep South in Louisiana, Mississippi, and Alabama. And what people can do now, and we're just getting our technology up and running, but they will be able to go into our website and they will be able to go into our design library, where currently we have about 30 different housing models, but which they can pick a 1-story model, single family, up to a quadruplex, and we go up to 3-story quadruplex, although Todd is working with us right now to design a 5-plex building. But we don't go higher than 3 stories currently at this time. But we do not say our designs are customizable, but they are configurable so that when someone goes in, they are able to make some modifications, whether they're adding porches or balconies, where they're putting the front door, or the back door, the side door. And so we do have some options to configure our housing models. And when people are making the changes online, our software actually is updating the core design. And all of that information goes into our core design, and then it drives our process all the way down. It creates our stamped permit-ready construction documents, which are digitally sent to building departments who have the digital twin to match them up. So it makes the whole permitting process a lot faster. And then it also informs, when somebody does order a house, it informs all of our suppliers, the lumber fabricators, the structural insulated panel fabricators, our light gauge steel fabricators, our steel roofing fabricators. All of that digitally goes to our suppliers so they know exactly the design, the color, the exact pieces that they need to fabricate and where and when it has to be delivered. And then all of that information is captured so that the home buyer or the developer, the builder, Shibusa, and all of our suppliers can see the dashboard to know exactly where everything is in a certain period of time. But the whole reason for that, like you said, having that distributed is so that we use suppliers and builders closest to the job site to cut down on carbon footprint and expense from shipping. And so when we do go to Europe and Latin America and other places, we will be able to send our shop drawings to local suppliers in those regions so that we always help bolster the local economy and use products from the local economy and builders from the local economy.
That's so interesting. I don't know how it is in the US because it's almost the size of Europe. But in Europe, we have, depending on where you are, there is, let's say, I see you, I guess you always build with wood. we have, depending on where you are, different types of wood that are available in larger amounts. So do you also change a bit the type of materials you use depending on where you are?
Yep. And Todd and I are smiling, right? Because here in the Deep South, we use southern yellow pine, and out west, they use Douglas fir, and they have different structural strengths. And so it does impact our design. And so Todd, if you want to jump in.
Yeah.
That.
I mean, it's a great question. That's probably one of the things that we can do pretty simply, is modify the wood species. That's fairly straightforward.
But we do, I mean, obviously down here in the Deep South, we are concerned with 150 mile an hour plus winds and flooding. And out west, we've had to modify our designs for earthquakes and fire. So it does impact our design and the materials that we use.
Yeah.
Okay. So it's a completely automated process. You designed the houses, and now all the builders know what they have to do. And then the let's say the home builder, the homeowner order the house on your website, everything in the color they wanted. It gets ordered, it gets shipped to the site. And then does the homeowner work with bringing the contractors, or how does that work?
That's a great question. So every region that we go into, Shibusa will train and certify builders so that only our trained and certified builders will be able to build Shibusa housing so that we can maintain quality control. So buying a house is one of the most expensive and emotional decisions that anybody will make. So we've realized that we need to maintain the personal touch with this. And so when somebody does go in and configure and order the house that they want, once they hit the complete button, it sends it out to bid to all the certified contractors in their location. And then the contractors, the cost to each of the contractors for the permitted construction documents and the complete kit of parts is exactly the same. So when the contractor bids on it to the homeowner, hopefully they're all within a pricing range, because what the contractor is going to bid on is giving that home buyer the total cost for delivering that house and the timing. So some builder may say, I can do it for less, but you have to wait 5 months. Another builder will say, I can do it now, but you have to pay more. So those builders then, those home buyers can then reach out and connect with each of those builders to talk more in depth about exactly what they want. Because basically what Shibusa provides is the cake, and a really great, wonderful cake. And then a lot of home buyers may want to put a lot of different frosting on their cake, so icing. So they can work with that contractor to add a lot of decorative detail or any custom modifications that they want to make. But otherwise, we give people a very solid, healthy, sustainable, resilient home.
Very cool. And another aspect that's interesting to talk about, we had at my studies at ETH in Zurich a few years ago, we had a semester that was called Building for Disassembly. So we had to develop a housing project with over 200 apartments that had to be completely disassemblable, if you say that.
Yep.
So the solution was to not glue anything. Actually, we started the semester by taking apart a car. Did you know that you can take apart every little piece? And we took a picture with
cool.
a whole car in the room.
That's so cool.
So how does the disassembly work for the Shibusa system and the recycling?
I could probably take that one.
Yeah, why don't you take that, Todd?
The homes are entirely disassemblable, except for the foundation, which is poured concrete. Our vision is to even be able to disassemble the foundation, because we'll be using helical soil screws, which can be drilled into the soil, and we can put the building on top, and then they can literally be pulled out the site is you know, with a little bit of care, it's returned to the way it was, which is exciting. But we use fasteners. All the fasteners can be pulled apart. All the timber framing could be reassembled somewhere else, or the timbers can be used in a different way. The SIP panels can be reused. So it's just the way that you think about making it easy to assemble is the same, by the same token, same manner. It's easy to disassemble. We don't glue anything together.
Have you already had a house to be
We've never disassembled anything, but
Oh, yes, we are.
oh yeah,
We
that's
are
true.
Assembling a house right now.
Yeah, it was built inside.
It was built inside our warehouse, and right now we're disassembling it.
That's great. Yep, there you go.
Oh, that's cool. Are you going to rebuild it, or like reuse the parts, or just recycle
Yes,
materials?
we're going to reuse the parts. Yeah.
Mm-hmm.
That's cool. There you go.
Yeah.
But it now makes me realize we should have filmed it.
Yeah.
Yeah,
there you go. Because the disassembly that's definitely, I love that you have a course on it. That is a disassembly, reuse, and creative reuse are.
Yeah, because we have our posts and beams are put together with our proprietary joint, and they're screwed together, so you can just unfasten them.
Yep.
Okay, so no glue involved.
No glue.
Yeah.
No.
Yeah.
It's entirely mechanically assembled. So it's not chemical. There's no chemical bonding required.
A few of you might know that I recently opened my own architecture studio, and I just started with the podcast. I'm very excited to build a platform where I connect with inspiring people to learn along the way and share these learnings with you. So if any little thing has inspired you, or if you learned anything new, I'd appreciate if you could rate the show or share my content on social media, Spotify or YouTube, or wherever you listen to it. And if you think there are any touch points between you and me, I'd be super happy to connect with you. Feel free to reach out on any platform. You mentioned before the permaculture book that made a big difference in your life. Can you elaborate on a few key elements that you learned there and how you implement them now in your daily work at Shibusa or at your own practice?
For permaculture people like myself, which is another way to think about it, is deep ecology. It's a group of us, and I think, and Shibusa really embodies this. It's people really care enough to study and commit time and resources to learn at a deeper level. I would recommend the book to you, Ladina. You'll
sure,
love
definitely.
it. You'll love it. Hold on a second. It's out of print. I have 2 copies. This is the book.
Oh, it's beautiful.
Yeah, that's cool. It's called The Designer Manual. It's by Bill Mollison. Bill was a genius. He passed away recently. I met Bill, worked with him a little bit. They talk a lot about patterns and systems approach to things. They get into the if you just look at the chapters, there's chapters on water and soils and climate factors and earth working, earth resources, and aquaculture and strategies of. So the formative ideas of permaculture are basically permanent agriculture. So Bill was a forest ecologist, an Australian, and made a simple observation that forests, mature forests, the forest system is self-generative. It needs no human input. And it's amazing at creating carbon life forms. And then our agricultural systems need a whole lot of high energy input, are not sustainable, and are terribly inefficient. So what does that play in the forest ecology that's not at play in the standard traditional agricultural systems? And those basic distinctions are what created the basic idea of permanent agriculture. So the things that I do differently in my practice, having studied permaculture and other earth sciences, is that I'm really good with water. issues around water. I'm actually a paid waterproofing consultant, but it's not just that. We did in our projects one of the first bioswales in the nation, where water comes out of a parking lot. Instead of going into a storm drain, it goes into a swale with plants in it, and that does two things. The planted bioswale, it stores the storm water. It filters a lot of the pollutants out. It lets a lot of the silty stuff fall out of the water, so it's cleaning the water. Most of the water then it percolates into the groundwater where we want it, right? We want our groundwater recharged, and that's helping our growth of our vegetation, our trees. And then the water that in a large storm, we're sort of flowing off the site, if you will. That water is filtered before it goes into our streams and our creeks and our rivers. So it's a very simple way to work with water. The first project we did, which was early 2000s, and this was again, just from a deep sense of understanding what water is and earth and wanting to recharge the groundwater, how it's feeding our trees on site and so forth. And I was also inspired by a project that had done this. But we were the first ones, I believe, to do it on a commercial level. We did it for a hotel. And we were able to save $250,000 by not hooking our stormwater system from our parking lots, the storm drain, into the city's storm system, because the city charges a lot of money for developers to hook into their storm system. We saved $250,000, which was just wow. That ties into what Katy was saying, doing high level green at the same or less, in this case less than conventional building. What does that take? What did Katy have that was really the source of that? She had a commitment to doing this. That's what it takes. If you have a strong,
there's a will, there's a way, right?
If you have a really powerful sort of commitment to doing these things, you find the way. And so that's what I did. That's what Katy does. This is how we work at Shibusa. So we're constantly learning. We're constantly applying best practices. We're inventing best practices based on a better understanding of what works and what doesn't work, and also a deeper commitment to, the planet, sustainability, our biological health, our, the imperatives that we're having to deal with right now. It is an exciting time to be a green practitioner, and it's an exciting time to be part of a Shibusa system, which has the potential of making, I've made like really intense differences on small scale projects, and with Shibusa, I have the potential to work with Katy and Mike and others to make a much wider impact.
Do you think we should shift away from sustaining the built environment, so from sustainable architecture towards more regenerative architecture?
That's such a buzzword right now. I was one of the ones that came up with the idea of regenerative architecture 20 years ago. And everybody dismissed it. Yeah, because I was like, why are we even talking about net zero? We should be talking about net positive, because our bank account is too low. We can't just sustain it. So we already have a bunch of leaks in the boat. Why are we talking about no more leaks? Well, we're already sinking. So we got to do better than that, right? So the problem is it's become a buzzword, and people don't understand what that is from an ecological point of view. So, Katy and Mike and I haven't really talked about sort of how Shibusa can be a leader in this conversation. I believe we can be, but I want to be authentic about it. And that is, right now, even the best of our projects are not really regenerative. It's a really tough nut to crack, and it really can't be done on an individual building basis. It has to be done on a more of a community basis. But if we're really talking about regeneration as an ecologically positive endeavors, things that have an ecologically positive. In other words, our biosphere. Are we actually creating a net positive endeavor within biospheric science? That's kind of deep thinking, and if we're not, then we're not doing restorative projects. So I think we got to be. I think it's it's an exciting distinction, and it's also a distinction that's got a lot of greenwashing around it. I don't, even though our projects probably are the most restorative of most any project in the country. I don't use that word to describe our projects. The other thing is sustainability is also, something that we're lazy around. I'll give you an example, like the LEED certification, which you're familiar with. You can have a LEED platinum building in a building that has an immense ecological impact. So there's something really wrong with the way we're thinking about sustainability and green. It does deserve, I think more a higher level of intellectual integrity than it's getting. And I think we will. I think at Shibusa, we use building science because it's a more comfortable and probably more accurate way to describe where we're at with building. Our buildings are. We're using best practices. We're saving a lot of energy. We're reducing our waste. We're really, are we sustainable? Can the earth sustain, doing, that's really a good question. It's a deeper question. But can we commit to reducing our impact? Absolutely. Is a Shibusa system going to make a serious reduction in impact? Yes. Our firm in Shibusa will be tracking our carbon, our embodied carbon, and our carbon outputs, and we'll have a lot more to say about this in the months and years to come.
Can you mention like 2 or 3 main factors that you think with all the certifications, whatever they are called, wherever in the world, they are all more or less the same, that we're tackling in the wrong way?
Because they don't have an ecological foundation. I mean, I would say there are some that are closer. There's like I believe this is what the regenerative conversation is really about. But it's not. It doesn't have the closest organization that deals with what I'm talking about is the ecological footprint people in Oakland. They were the ones that came up with the overshoot day, where there's a day which we hit now because we're ecologically not. The Earth produces a certain amount of ecological goods and services, right? Stuff, lumber and trees and oxygen, right? Each year. And humanity is now using up that year supply of production sooner than a year. So they call it the overshoot. Once you've used up the year's bank account of stuff, of ecological goods and services, you're now borrowing from the next generation. You're taking out forests and things like this, right? You're going into debt, ecological debt. So we're in massive ecological debt, and this is one of the things that is not even a carbon issue, right? We're not even talking about climate change. We're just talking about ecological debt. So the deep ecologists like myself, we think about this stuff, and it informs our work. Kudos to Katy and Mike for wanting to work with an architect who's this obsessed with natural systems and all that stuff. But fortunately, I'm also good at the other stuff, practical stuff.
So, Katy, question for you before I get deeper into that with Todd. If there was one sustainable practice or technology that you could make universally available today, what would that be and why?
Wow. We really believe in incremental. So there's no silver bullet. I mean, for our housing sustainability and resiliency and being economical, it's every little tweak that we do. I think probably one of my biggest issues is with conventional construction is all the lumber waste. And I think that's one of the greatest things about our system is we really use trees efficiently. Wood sequesters more carbon, and you see all this 3D printing where people are printing with concrete, and concrete embodies more carbon. It's like the worst building material. But so there's got to be kind of a happy medium in between. But I think that conventional construction just wastes so many trees, and there's got to be. That's why we're all about efficiency on site. But there's not one practice per se. I mean, we've just really tried to look at every nail and every screw. I mean, our digitized designs are down to the nail pattern in a home, so that the people that build our homes know exactly where the nails go, how many to use, so that we don't overorder, we don't waste. Everything is really consistent. And, we've also tried to keep everything very simple and practical, because we need many more people to go into home building in order to solve the housing crisis. I mean, we have a housing crisis because we just don't have enough home builders. And, when you're pulling people off the street to just throw them onto a job site, they're super wasteful. So you really have to have a system that really helps ordinary people become extraordinary home builders. So I think as far as the one thing to do about sustainability, I was fortunate to grow up in a super environmentally conscious family. And then also California, which leads the nation in sustainability. But coming down here to the Deep South, people still litter, and, they sit in their cars with idling for hours, and there's just no education here. So I think, when you talk about sustainability and resiliency, and 90% of the population here doesn't even know what that means. So I think to really improve sustainability or do something sustainable, it starts with education. But there's no one great solution or thing out there. I mean, I'm hoping that we're going to be it. But it's because we've done little incremental changes to take a house from being $500 a square foot down to $200. And every little thing that we do that cuts $1 off. And people don't realize, that's a couple more thousand. Sure, all the wealthy people in California or Zurich, they can afford a couple more $1,000. Not here in the Deep South. So every little thing we can shave $1 off a square foot makes a big difference. But it also, we don't want to cut corners and use petroleum-based products and do cheap construction. I mean, we've got it. It's a dance. How do we keep costs down and improve sustainability and resiliency, keep things healthy and attractive? It's a Rubik's Cube. Every time you do one thing, you've got to make sure that it doesn't totally negatively impact another area. So that was a long answer, but I've never tried to focus on the one leading sustainable thing. It's a whole series of solutions.
So more holistic approach. Do you ever experience with innovative building materials or even working with steel instead of wood?
Absolutely. All of our interior walls now are light gauge steel because we can make them open panels, but they're light and easy to just put into place. And so we do use light gauge steel for that because it also allows us to pre-plumb and pre-electrify, but it also allows us to keep it open so that when inspectors come in for the bank and for the city, they can easily inspect it and see what's been done and that it's been done to code. Yep. And then we discovered a company here in America out of North Carolina called Planted. And they're a solution that's an answer to plywood and drywall. Plywood is wood and it's expensive, and drywall is gypsum. It's mined. Drywall, not only is it not a sustainable material, but when you put it in a home, it's super labor intensive. And this company out of North Carolina has been able to create board sheets very similar to plywood, but made from grass, ordinary grass that can be grown anywhere. And so we're really hoping to work with these people because they can build factories all over the country to make really great sustainable boards that instead of doing drywall on the interior homes, we can put these pre-painted boards in and save ourselves 7 days of labor and thousands of dollars, and just use a very sustainable building material. So we're constantly looking for new materials and new solutions. And we don't want to have to reinvent the wheel and manufacture and do all that ourselves. We want to just be able to plug and play whoever the leader is out there.
Todd, talking about or getting back to I totally agree with Katy that education is the way to go. That's also why I started this podcast, because I think the word sustainability is misused a lot of times. It's being commercialized or just used without any meaning anymore.
Yeah.
So you talked about regenerative architecture and sustainability as well. So if there are two things that you want to share with the people that they can use or change in either in their daily life, not as architects, as homeowners, everybody has a home, or also as architects, could you share those?
I would start with composting. I would start with stop putting your vegetative and your food waste in the trash. That's such an easy thing to do. Compost it. When you put food waste in the trash, you put it into a landfill. It goes into anaerobic digestion. So these are the things you learn when you study permaculture. That anaerobic digestion is way worse than aerobic digestion. So anaerobic digestion is when there's no air present, and there are bacteria that will digest that. There are anaerobic bacteria that are in our gut, and what they create is methane gas. That's why the bay shores that don't have any, they're breaking down material in a water environment with no oxygen, smell like methane gas. Smell bad. So that's what happens to your veggies when they go into a landfill. So it produces 30 times the negative impact of you composting it, which is also it's also putting carbon dioxide in the atmosphere, but it's 30 times less global warming impact. So I would start with composting. The other great thing about composting, anybody can do composting. You can do it in an apartment building. I was doing when I lived in San Francisco, an apartment building, and I asked my landlord if I could build put it in the backyard. Most municipalities take green waste now. I'm sure Zurich does. That's such an easy thing to do in terms of lifestyle, a lifestyle change. The other thing, everybody knows the other things. I would say electric vehicles really are important. In a way, I was thinking, Katy, about the waste, the sort of complete distinction around waste that a Shibusa home is over a conventional home, and efficiency is very true of electric vehicles as well because of regenerative braking. Because when you want to slow down an electric vehicle, you just pull your foot off the accelerator. The motor goes in reverse polarity, which means that it's now becoming a generator. It's generating electricity. And you'll see that positive thing go in on the dashboard of an electrical vehicle. I've been an EV owner for 10 years. So right off the bat, just in the operation of this vehicle, you're talking about a 30% savings of energy right off the bat. Just a change in technology, not a change in driving car weight, any of that stuff. 30% more efficiency in just the BTUs, in conservation of BTUs, right? British thermal units, this basic energy, the way we measure energy. So Shibusa does the same thing right off the bat. Just in the way these things are put together, we're saving 30%. We have 30% less waste. That means we have that much less burden, right, on the environment. We have that much less. We're saving that much more on cost in not having to purchase this 30% of materials that we're throwing in the landfill. So I would say those two things are. There's a lot of those are the two things. Just in terms of your question about what can a homeowner do. Take public transit would probably be the other thing. Lower your carbon footprint. And I'll end with this. You can also offset all of this stuff by simply paying for, especially people with means, simply paying for going to a website and paying a carbon offset. Very simple to do, makes a massive impact.
Does it?
Absolutely. Massive impact. The people who are doing really good carbon offset stuff, they're planting mangrove forests. They're buying up forests that otherwise would be cut, and a mature forest that you save from being cut for lumber, that is a mega difference, because the mature forest embodies carbon at a obscenely high rate, because these are already big trees and they get big way faster than a smaller, like just planting a forest. So the people that are serious about carbon offsets, and there are some really good companies, investing in those companies, everybody should be doing it. Sadly, of course, there's no there's no market, they're not advertising and stuff like that. So this is just, doing good for the sake of doing good.
I have seen some putting pressure on all the people who use corporate jets.
Yes.
That they
They should be doing offsets. Yep.
They can afford it.
They can. Well, there's a lot of people that can. It's also kind of amazing how little an offset can cost. Like, right. It's like $35 for a flight across the country to offset that carbon. Mm-hmm. That's affordable to a lot of people.
Yeah, very interesting. So thank you so much. It was a pleasure to get to know both of your works and thoughts about sustainable architecture. If people want to follow your work or know more about you, where can they find you?
Todd, you go first.
Well, you can find me at Todd Jersey Architecture. My email is Todd@Todd Jersey Architecture. I can give you my cell phone, 510-334-3626. Probably should reserve that for if you want to hire us or big questions.
And I'm, again, Katy Reynolds, and that's Katy. And last name is Reynolds, like in Reynolds Wrap, REYNOLDS. And my email address is kreynolds@shibusasystems.com. And Shibusa is SHIBUSA, and systems SYSTEMS.com. And Shibusa, we did not get into, is a Japanese term that translates simple, practical, and elegant. And that's how we design our houses and try to run our business every day.
Are you on social media?
Shibusa has Facebook page, Instagram.
I'm on Instagram. If I post our shorts, can I tag you?
Absolutely.
Shall I just tag Shibusa?
Yeah, and we're on LinkedIn as well. Mm-hmm.
Okay, cool.
Yeah, I'm on LinkedIn. You can tag us on LinkedIn.
A huge thank you for listening. Make sure you subscribe to the show wherever you listen to the podcast to support me and so you don't miss an episode. And while you're there, I'd also be so grateful if you could rate and review us. If you have any guest suggestions or any feedback, you can find me on the socials at LadinaShip. Thanks.